So this is the syllabus. So what is the grinding? So grinding maybe you are come across in lot of places, especially in your workshop when you're first year and when you're doing in fitting operations, or maybe you are doing about carpentry, chiseling. So there maybe you seen one rotating wheels. So two rotating wheels side by you seen. So that is called as a grinding. I think grinding image I've missed it. So this kind of tool maybe you've seen in your workshop. So this is called, this is nothing but a grinding. So this is the motor in center, and here you having a two wheels. So these two wheels called as a grinding wheel. So using this grinding wheel, normally what we will do, we used to finish our cutting tool in the workshop. That maybe in the chisel, or maybe your fitting tools, or maybe your carpentry, saws, those things. If any kind of blunt is happened on the cutting tool, they used to use this one. So this tools is called as a grinding tool. So nothing but grinding machine. So this is the grinding machine. So what is grinding machine? So grinding is a material removal process accomplished or nothing but performed by a wheel rotating at very high surface speed. So whatever the grinding wheel I shown you, maybe I missed it here, maybe I can add it one image. So unfortunately I was missed that. So that whatever the wheels you have seen just now I've shown you, so the wheels are rotating at very high speed. When the wheels are rotating, if you bring very near any kind of object, whether it's a cutting tool or very any kind of material, if you're bringing near to that one, it is remove the material on the surface. So whatever the excess material, whatever the unwanted material is there, it used to remove. So this process, removing of the material by a rotating high speed rotating wheel, is called as the grinding machine, or nothing but grinding operation. So this machine is called as a grinding machine. So in this, any rotating object, if you take any wheel is rotating, if anything is rotating, if you bring any kind of workpiece, so is it removing the material? No. For example, if you take, you having a tire is there, you having other kind of rotating discs are there. If you take remove any workpiece near to that one, what happens? Instead of material removing, you are cutting your disc is going to damage. So the disc is going to deform. But here it is not happened, because one thing is there, it used to have very strong the wheel. At the same time, here on the wheel we used to have some kind of sharp edges are there. So wheel here in this grinding wheel, so wheel consisting of a abrasive particles that are contained in the bonded wheel have more cutting edges. So what is there in this grinding wheel? Actually, grinding wheel is made of some kind of abrasive particles. It is not like normal wheel. It's not a not metallic wheel. It is a grinding wheel. Normally, grinding wheel made of some abrasive particles. So assume abrasive particles are nothing but your like a sand particles, right? We used to have sand, right? So in that we used to have, you can see very small particles are there. So here also an abrasive wheel also made of that kind of small particles only. So that small particles used to called as a abrasive particle. So these abrasive particles are joined together by a bonding medium. So that's why this abrasive particle, each abrasive particle is acting as a cutting tool. So these abrasive sharp points is removing the unwanted or nothing but material from the surface of the workpiece. So that's why the total grinding wheel consisting of many cutting teeth. Maybe next slide you can see. Actually, this is if you magnified and if you put a microscope on the grinding wheel, and if you see the grinding wheel, so grinding wheel is look like this. So even though you from distance it can look like a wheel, but if you go in near, so there is some kind of sharp edges are there on the wheel. So this maybe you can see. This is a one sharp edge. This is sharp edge. Some sharp edges are there. So these sharp edges, whatever is there, nothing but your abrasive particles. So these abrasive particles, when coming in contact with the workpiece, they're removing the material, because these abrasive particles are very small in size compared with our previous whatever the work cutting tools we have studied, whether it's a milling cutter or whether it is a grinding your lathe cutter or anything, shaper, slaughter, whatever the cutter, compare with the cutter. So these particles are very small in size. So because of small in size, material removal is very less here. Very small, minute size of material is removing. That's why whenever the grinding is performing, you cannot see any kind of chips coming out from the surface. Whether it's a lathe or whether it's a milling, you can easily see there is some kind of chips are coming out from the workpiece. But in grinding machine, normally we cannot see any kind of chips, but we can see some kind of spark. So whenever we are grinding, we can see some kind of some small spark is coming out from at contacting point. So this spark is nothing but whatever the heat is generating, because the wheel is rotating at very high speed. So this high speed wheel with this small contact of abrasive particle, so then there is a kind of heat is generating. So that heat is coming out in the form of a spark. So that spark you can see, and that spark is normally not harmful. It's not burnt your skin, but little bit hot. So even sometimes, normally we try to avoid contact those kind of sparks, but still if it is having contact with your body or any other material, it is not melting and it's not very hot also. But always you need to be careful when you are grinding. So because when you cannot see the chips are coming out, but very small particles of metal is coming out, so that material can fall on your body or maybe on your eyes, that may harmful to your body. So you need to be very careful when you are grinding. So this grinding is nothing but the rotating grinding wheel consisting of many cutting teeth, whatever I've seen just now. These cutting teeth is nothing but abrasive particles, and the work is fed relative to the rotating grinding wheel to accomplish the material removal. So as grinding wheel is rotating at very high speed. So on this grinding wheel used to have very sharp edges. So when you bring any workpiece near to this edge, so then this edge will try to remove the material from the surface. So this is the main cutting process happening in the grinding. The same thing, whatever you see here, the same thing is there. So this is a grinding wheel. Microscopically, if you check it on the microscope or maybe under your lenses, if you see, so you can see this kind of edges when this is rotating and this is stationary, right? You're keeping in your hand, or maybe you can mounting on a table or anything. So when it is grinding, it is passing through this. So this whatever the sharp edges are there. So these sharp edges are removing the material in the very small layer. So here layer is not thick as you studied in lathe or milling. The layer of material is very small here, because you see the contact surface or nothing but contact point of the cutting tool is very small. That's why whatever the particles or whatever the chips are coming out from the workpiece is very small. So this is the basic working principle. So in grinding is the process of removing material by abrasive action of a revolving wheel on the surface of workpiece in order to bring the required shape and size. So as I already told you, the same thing, removing of material by a rotating wheel which is consisting of a abrasive particle. So because of this this contacting action or nothing but impact action of this small abrasive particle, material is removing from the workpiece. So the wheel used for performing the grinding operation is known as the grinding wheel, because this wheel is using for the grinding. So this process, removing of material using this kind of small abrasive particles, is called as the grinding. So this whatever the wheel we are using, so made of abrasive particles, so this wheel is called as a grinding wheel. So it consisting of a sharp crystal or nothing but sharp edges called as the abrasive. So whatever the particles are, whatever the edges is all, that's called as the abrasives, held together. So these small particles, because you're seeing big size of wheel is there, which is maybe having something 20 mm or maybe 100 mm, 200 mm diameter wheel is there, but that wheel is consisting of very small abrasive particles. So how these abrasive particles are holding together? So these abrasive particles are held together by a medium called bonding material, nothing but used to call it as a bonding agent, some bonding material we are using. So these abrasive particles are joined together by a binding medium. Like whatever we are making in our home, if you want to make any kind of walls or anything, we used to use some sand we are using as a medium, and as well as first this sand to combining this, we are adding a cement, right? So here, their cement acting as a bonding agent. So here also same thing. So here also we are using some kind of bonding agent. So in that bonding agent, you are adding to this abrasive particle. So it's giving a shape. If without bonding agent, you cannot make the whatever the small abrasive particles, even in the thousands of number, so millions of number it is there, you cannot make in a shape or in an object say size or shape. So until it don't have the bond. So if it is bond is there, then only you can make into the wheel. That's why in grinding wheel consisting of both. One is abrasive particle, which is doing actual cutting of the material, plus it used to have a bond also, so nothing but bonding agent, which is holding together these abrasive particles. Just assume abrasive particles is nothing but a cutting tools. So these cutting tools are bond together by a bonding agent, that's called as a bond. So through this together, this only you used to have a grinding wheel. If anyone is not there, you cannot call it as a grinding wheel. If it is abrasive particles are not there, just simply you having a bonding and it is in the form of a wheel, you can call it as only wheel. You cannot call it as a grinding wheel. If you want to have a grinding wheel, you need to have a bonding. At the same time, you need to have a sharp cutting edges, which is coming through the abrasive particles. So every grinding wheel is consisting of abrasive particles as well as bonding agent, or nothing but bond. Both are required. So the wheel may be a single piece, or maybe solid type, or maybe compressed of several segment of abrasive blocks joined together. So wheel is maybe single wheel, or maybe it having a two halves of a circular disc can be joined together, or maybe some small sector of the wheels can join together and finally is make in the form of a wheel. any kind of things may be there in the grinding wheel. If a small grinding wheel, maybe you can see it as a single object or single wheel. But if it is a big, so this big grinding wheel is joined together by a small segment of the segment of wheel. There may be small two halves or three halves. Maybe multiple portions also can join together and form a big wheel. So grinding wheel is made of any of these things, whether it's a single wheel or maybe part of the wheel is joined together and forming a wheel. But finally, always grinding wheel is look like a wheel only. It's a disc, cylindrical disc shape. So normally what happened in grinding, so what I suggest you before going for this, maybe take a screenshot of this. Otherwise, maybe students can note down these points, because this is one of the important questions may come from the grinding. If you're asking about what is grinding, so maybe you can write these 4.45 points plus whatever I explained to you, that maybe you can write it. Please, everybody can take a screenshot. I will give you 10 seconds time, then I will go for next slide. So I'm not going to share slides after the class. I hope everybody know that. If somebody is not doing, I cannot help anybody. So fine. So I'm going for next slide. So grinding mechanism. So how this grinding is happening? The same thing. Whatever before this slide, whatever I explained to you. So the engages an abrasive tool. So whatever the particles you see. So whatever the particles here. So these are the abrasive particles. So these abrasive particles. This is nothing but your workpiece. So this is abrasive particles are joined together by this bond. So this is nothing but a bond. So these are here also similar kind of things are there. So not a separate wheel may not be there. So here also some this kind of edges are there and they're bonded together by this kind of bonding material. So in this, whatever the hatch portion it's considering as a bond, and whatever the plain portion you can see, this is nothing but abrasive particle. So engage an abrasive tool whose cutting elements are grains of abrasive material known as a grit. So in this, whatever the abrasive tool, so this is a grinding wheel, it's considering as abrasive wheel. So this abrasive tool or abrasive wheel is contacting with the workpiece through this, whatever the sharp edges. So abrasive particle, so joined by a bonding agent. So cutting element, and these edges is called as a grit. This abrasive material known as a grit. Grit is nothing but in unit cross-sectional area or in unit surface area, how many number of abrasive particles are removing the material. For example, if you see from here to here, you having 1 centimeter square. So in this 1 centimeter square, how many number of abrasive particles are there? How many cutting edges are there? Maybe you see from here to here. So in the assume it is a 2 centimeter square. 1, 2, 3, 4, 5. 5 grains are nothing but 5 abrasive sharp edges are connecting to the workpiece and removing the material. So these how many number of grains are removing the material is called as a grit. So grits are characterized by sharp cutting points. So this cutting edge is nothing but a cutting point, right? So this grit is nothing but sharp cutting points. How many number of points are there in unit cross-sectional area? High hardness. So this whatever the grit is defined hardness, wear resistance, and also chemical stability. So because normally in cutting tool, properties of cutting tool when we see, so we see all these properties, right? It has to have high hardness because heat is generating. So material has to withstand it even at a high temperature. This whatever the abrasive particles are there. So these abrasive particle can withstand the hardness. Similarly, wear resistance. So material, this whatever the these sharp edges are there, it cannot wear out. So it has to have wear resistance. It has to withstand when you're coming in contact with the workpiece. So these whatever the abrasive particles cannot separate from the wheel. Instead of separating the wheel, they need to remove the material. So maybe you can see like this. They need to remove the material in the form of a very small chips. So that is coming from the wear resistance, and also chemical stability, because here in whatever the bonding and whatever the abrasive particles having a different elements are there. So those different elements maybe you are going to see in the next few slides. So these chemical, it not has to have any chemical reaction between the abrasives or bonding agent with the workpiece. So it used to have a chemical stability also. So all these properties are required. All these properties are defined by the grit, and nothing but properties of the abrasive material. So sharp cutting point, high hardness, wear resistance, and chemical stability is required for these abrasive particles. So here figure illustrate the cutting action of abrasive grits of the disc type grinding wheel. So this is a typical disc type of grinding wheel. So in that whatever the cutting edges are there, this considering as a grit. So this is showing the whatever the removing action is there. So this is showing as a grit or nothing but your material removal process. So this is a typical grit grinding mechanism. So please take this also, note down in your notes. Otherwise, take a screenshot of these things also, this slide also. Going for next slide again. So types of grinding machine. So this is about grinding mechanism. So grinding wheel, abrasive particles, bonding will be there. So all these details we can learn it later. So but for next we can see what are the different types of grinding machines are there. So grinding machines according to quality of the surface finish. So it may broadly classified into two categories. One is rough or non-precision grinding, and second one is the precision grinding. So whatever the grinding wheels in our workshop, in our machine shop, if you see, it is mostly it's a precision grinding because it used to make a very sharp cutting edges. It's making. That's why it used to call it as a precision grinding because it needs to made a cutting tool very sharp, as well as it has to maintain the angles. So whatever the angles we are seeing in the starting of first chapter, that is rake angle, clearance angle, other angles, whatever relief angles, whatever angles is there. So that angles has to maintain when you're grinding. That's why normally this kind of tool and cutter grinder is considering as a precision grinder. Similarly, not only tool and this some types, maybe you see after welding, whenever you're doing welding, so after welding, maybe you'll find some kind of sharp weld bead is forming on the joint. So this weld bead is removing by a grinding wheel, right? So initially, whatever the things are, they'll be removing. That kind of process is called as a rough grinding or nothing but non-precision grinding. Just you are removing the material, whatever the weld bead is there, which is formed on the joint, that we are removing. So that kind of grinding is called as a non-precision, nothing but rough grinding. So after rough grinding, after removing this material, maybe further for finishing of this surface, so maybe again you need to do for a precision grinding also. But normally those kind of grinding is considering as a rough grinding. So again, this rough grinding is nothing but non-precision grinding to remove the more stock than other grinding process. Normally it is using for rough grinding. This rough grinding we use to remove the more material than precision grinding. Precision grinding normally using for removal of material very small in quantity, whereas in rough grinding is very large in quantity, more number of material we can remove. But remember, so grinding normally material removal rate is less compared with all other operation till now what we discussed. Whatever the lathe, whatever the milling operation, whatever the shaper, slaughter, planer, or drilling, among all the material removal rate in grinding is less. So in that also, rough grinding is moderately little higher, but precision grinding is still further less material removal rate. So normally, if you take the depending upon the location where we are using, maybe you can classify the grinding machines as floor stand or bench grinder, which is using on the floor. So whatever grinder we are grinding, we have seen in our workshop, it is nothing but a bench grinder. So it's general purpose grinding. So in there it's portable and flexible. Sometimes we used to have a portable also we can carry. Like normally in grinding or in after welding, whatever the grinding wheel or grinding machine we are using, it's normally portable grinding machine. Similarly, swing frame grinding machine, abrasive belt grinders also there. So these are the few grinding machines are there. So this maybe we can see after a few slides. So next, if you take the basic types of grinding machine, depending upon its other factors, so maybe we can classify it in the rough grinding as well as the precision grinding. So rough grinding, again, there is a different kinds of rough grindings are there. So floor standard grinders, so clench grinder, portable grinder. Normally portable grinder is nothing but you can carry wherever you want. Abrasive belt grinder is nothing but a kind of belt is there. So using that belt, we used to remove the material. So this is nothing but similar to your the disc whichever you are used, nothing but polishing disc whichever you are used in your MMS lab. Similar to that, this is the portable grinder, this abrasive belt grinder. Similarly, sling frame grinder. So in that we used to some kind of frame is there. Maybe I can explain to you in the next slides. And next coming to be precision grinding. So in precision grinding, normally we used to classify it as a cylindrical grinder as well as the internal grinder as well as the external grinder. So normally cylindrical grinder we can considering as an external grinder. So external grind is nothing but it is grinding the outer surface of any circle or any kind of cylinder. That is called as a cylindrical grinder or nothing but external grinder. In cylindrical grinder, again, there is a three types of grinding machines are there. Center type plain grinding, center type universal grinder, as well as a centerless grinder. So these things in detail, maybe we can see in the next slides. Then is coming to be internal grinders. Normally internal grinders are nothing but internal features like inside of the pipes or inside of the bodies, whatever the material we are machining. So that is called as the internal grinder. So in this internal grinder, again, there is a different categories are there. Checking type grinder, planetary type grinder, and also centerless grinders. So these are the few classifications. In exam, if anybody is asked you the types of grinding machine, please write this as your answer. So rough grinding, So rough grinding maybe 5 classification, and precision grinding in that maybe 2 classification. In each classification again 3 different types of grinders are there, and further the grinding classification is there in the next slide. So before going for next slide, please note down this slide. So note down the slides, or maybe we can take a screenshot. Now, this is a few more classification. Then is coming to when cylindrical grinding with internal or cylindrical grinding. Then third category is surface grinder. So normally surface grinder is using to grind the flat surfaces. So reciprocating table, horizontal spindle, rotating table, horizontal spindle, reciprocating table, vertical spindle, rotating table, vertical spindle, as well as a horizontal rotary table, vertical spindle. So these are the 4 categories in surface grinding. Similarly, tool and cutter. Actually, that is not end, the tool and cutter grinder, and also special grinders. So special purpose grinders also is there. So these are the basic classification. So precision grinding, these are the 5 different types of precision grinding, and 5 different types of rough grinders are there. So in the exam, if you're asking the question, maybe you can write these answers. I'm going for now individual grinding. Floor and bench grinder, the basic general purpose grinding, whatever we have seen. So that is nothing but floor and bench grinding, which is I've shown you in the starting of this class. So these are the general purpose grinding machine. The floor, this is the bench grinder. So whatever the grinding wheel, the grinding wheels are there. This is the motor. So if it is mounted on a table, it's called as a bench grinder. The same machine, instead of mounting on the table, it used to have a very long pedestal. On pedestal, this pedestal is directly mounted on the floor, and on this pedestal, if you're mounting this setup, then it is called as the floor or pedestal grinding. Floor grinding, why? Because it is mounted on the floor. So on the floor you used to have a long pedestal. That's why this used to also called as a pedestal grinder. It's used to called as a floor grinder or pedestal grinder. Some books it's calling it as a floor grinder, some books it's calling it as a pedestal grinder. So these are the general purpose grinding machine. So if you see in this, so grinding of various material and cutting tools in tool rooms. So whatever the tool rooms are there, so in that normally whatever we're using these kind of grinding machines are there. So even in foundries, in general repair shops, all these places, maybe you can see these kind of general purpose grinding machines, floor or bench grinding machine. So horizontal spindles having a grinding wheel mounted on the both ends. So whatever you see in this, so this inside we are having a motor. So on this motor you are having a spindle. So two sides, 2 spindles are there. So each spindle is mounted in this wheel. When a spindle is rotating inside, when motor is rotates, that is rotating the spindle. So that is rotating the wheel. The simple mechanism is there. So horizontal spindling having a grinding wheel mounted on the both ends. It can be suitable bolted on the bench at convenient height. So whatever the motor is there, so on that, whatever the spindle, on the spindle, it is the whatever the grinding wheel is there, the grinding wheel used to bolted on it. The floor or pedestal grinder is a bench grinder mounted on a steel stand or pedestal of suitable height, as I told you. So there is no difference between pedestal grinding and bench grinding. Only thing, in bench grinding, you used to have a very small pedestal. And normally you can say that there is no pedestal. Here you used to have a long pedestal is there. So on the long pedestal, you are mounting your grinding wheel. So that's only difference is there. So both are almost working principle. Everything is same. The horizontal spindle carrying the grinding wheel is normally an extension on both sides of the armature shaft of the motor. So inside a motor is there. In motor, maybe in basics of electrical engineering, maybe you studied. So inside the motor, you used to have an armature and a coil, right? Coil on this, there is a shaft is there. Shaft is rotating. So on this shaft, you used to consisting of axles at the both ends. So on the axles, you are mounting these grinding wheels. So these grinding wheels are also used for polishing by replacing the grinding wheel by a polishing wheel. So grinding wheel and polishing wheel is not much difference. So in polishing wheel, maybe you used to have very fine grains are there. So whatever the abrasive particles are there, very fine. So removing very small material, but they used to have very good precision. So there is a difference. There is only the difference between the precision grinding and rough grinding. If this rough grinding, whatever the grinding machine, instead of removing the rough grinding wheel, you can put the precision grinding wheel, then this machine is calling it as a precision grinding machine. So the main important part of any grinding machine is this grinding wheel. So whatever the wheel, maybe you can see. So whatever wheel I'm showing to you. So this thing, whatever you see, so this is a more important part of any grinding machine. This is the grinding wheel. So this is only removing. This is only the driving part. So this, if you want to have the rough grinding wheel, this is called as a rough grinding machine. If you remove the rough grinding, you keep it as a fine grinding machine, then we can call it as a fine grinding or nothing but precision grinding machine. So we can go for next slide. So this is a portable or flexible shaft grinding machine. So here not having a two edge extension like whatever you have seen previously, you used to have a motor. So this motor is mounted on a floor, and this motor is connected to a very long and portable or nothing but flexible shaft. This is considering as a shaft. So inside this, you having a connection is there. So that is rotating this object. The flexible shaft. This is having a flexible shaft. This is the motor. The flexible. This is a motor. This is completely flexible shaft. At the end, you need to maintaining a cutter or nothing but your grinding wheel. So reburning circular brush or nothing but grinding wheel. So if you keeping a brush, it's become a polishing. If it is a keeping as a grinding wheel, it's become a portable grinding wheel. So this is nothing but, so this is the actual grinding tool, whatever that wheel we are used previously. So that wheel, very small. It's not a heavy wheel. So in portable grinding machine or maybe in bench grinding machine, in bench and pedestal grinding machine, we are using heavy grinding wheel. But here we are using a little light in weight grinding wheel. Nothing but is cutter grinding wheel, or maybe we can keep it as a cutter in this. And when it is rotating, so when is this rotating cutter is bringing to the workpiece, this is removing the material. So this is the main the grinding wheel which is there in the normally using for industry. This is called as a plane center type grinder. So this plane center type, it is similar to your lathe. Maybe you can see in the lathe, same kind of setup. One side you having a one letter headstock, and other side it's tailstock. But here this is come this side and this is come this side also, any side. So here it is considering as a headstock, and this is a tailstock, and this is whatever the tool post is there in your lathe. So the tool post is replaced with a grinding wheel. So grinding wheel setup is here. So your workpiece is mounting between the two centers. So here maybe you have seen in your lathe there is a two centers are there. So dead center on tailstock and live center on headstock. So in between these two centers you insert a workpiece. So when as a headstock is rotates, the workpiece is rotating. So same thing like lathe. So when rotating workpiece, you are bringing close this, whatever the grinding wheel is there, if you bringing close this one, even if grinding wheel also is rotating on this, so both are rotating means there is a high relative velocity is there between the cutting workpiece and cutting tool. So because of this high relative velocity, this is a typical grinding. So removing all this tailstock, headstock, nothing is showing here. Is showing only two things. This is your workpiece and this is the grinding wheel. So if this workpiece is mounted between the two centers. So this is one center and this is one center. So this head, just assume it as a live center or nothing but headstock. The tailstock, which is having a dead center. So in between these two, you having a workpiece. So these workpiece is rotating because of movement of your headstock. And similarly, this whatever the grinding wheel is there. So this grinding wheel also mounted on a shaft. So this also rotating. So this is rotating in one direction and this is rotating other direction. So because of this, you used to have very high velocity. So in previously in lathe, your workpiece is rotating, but your cutting tool is stationary. But in grinding wheel, both are rotating in opposite direction. You see, when both are rotating in opposite direction, relative velocity is very high. Under this relative velocity, whatever the small size of particles are nothing but your abrasive particles, cutting parts are coming in contact with the workpiece, is removing the material very huge. Even though it's very small in quantity with each sharp edge, but number of edges are going past to the workpiece is very fast. That's why your material removal rate in grinding is very high. So this is about plain center type grinding machine. So these are the parts, the grinding wheel, grinding face. So wheel, spindle, all these things are there. So in that, as I explained to you, this is the wheel and this is the workpiece. So this can be travel also workpiece. I think you're having a very few seconds are left out. So what I will do, so maybe we can take a break here. So immediately after the break, once this is closed down, you join back. Meanwhile, you can take the image print of this slide. So this is about center type grinding actually, because the workpiece is mounted between the two centers. That's why this used to called as a center type grinding. So maybe we can, now it is 12:50. So maybe most probably by 1:15 I will stop my class. So please pay attention up to that. The cylindrical grinder. So cylindrical grinder, center grinding is also called as a cylindrical grinding. Why? Because, so this is a typical central grinding. Maybe you can see. So you can, even if you're asking for 2 marks about grinding process, 2 marks or maybe 3 marks if they ask. So this one rough sketch maybe you can show. So about cylindrical grinding or maybe surface grinding. So your whatever the grinding, cylindrical grinding, surface cylindrical grinding. So your workpiece is this one. So this workpiece is held between the two centers. So and this is your grinding wheel, nothing but grinding tool. So this grinding wheel, so this is rotating about its axis, the rotating workpiece as well as your wheel also rotating. That's why your this cutting action is very fast here. So center type, so the workpiece is held in the centers by a chuck or in a suitable holding fixture, rotating it about its axis. So here maybe chuck is there or maybe any other device like collector or any other things, whatever we have seen in previously work holding devices. Any work holding device may be there. So using this work holding devices, that's holding the workpiece, and this workpiece is fed against the grinding wheel. So when fed against the grinding wheel having the sharp edges, that sharp edges removing the material. So traversing of wheel or work is done either by the hydraulic or a mechanical power or by hand also. So the whatever the rotation is there in this rotation can be done by electrically or maybe as hydraulically, or sometimes with very small speed maybe you can manually also you can drive. So manually also you can drive this. So this rotation. So feed is given by manually or power or by hydraulic forces. So if asking you the 2 marks, 2 marks or 3 marks, maybe I want a student to be show this. So whatever the things are there in this, that maybe you can show to them. So write in your exam paper. So next I'm going for next slide. So traverse grinding, workpiece is reciprocates. So here normally what happened, workpiece is reciprocate and grinding wheel is rotates. So cylinder with the length longer than the width of the wheel can be grinded. So if you want to have the length of the workpiece is longer than grinding wheel width, whatever the face of the grinding wheel, so then definitely you need to have a reciprocating motion is there for to grinding wheel. The workpiece is reciprocates, or maybe grinding wheel can be reciprocate. Anyone can be reciprocate and other can be stationary. Even sometimes both can be reciprocate. So cylinders with the length longer than the width of the wheel can be grinded. Right. So plunger type grinding. So workpiece rotates on the fixed position. Wheel feed to produce. Plunger type grinding machine is nothing but your workpiece's length is less than the whatever the width of the grinding wheel. So workpiece rotates on the fixed position. You're not changing the location. Wheel feed to the produce the cylinder of the width equal to the wheel. So whatever the wheel size there, it has to passing through. If you see in this, if width is smaller, so this is not reciprocating. It is going into this one. So as it's going into this one, it's removing the unwanted, whatever the material is there on the surface, it can remove. For mounting the small wheels, an auxiliary shaft is provided, which runs at the relatively much higher speed than the motor, as I told you. So this whatever the grinding wheel is there, so grinding wheel is normally mounted on the auxiliary shaft. So main shaft is mounted on the workpiece is mounted on the main shaft, and auxiliary shaft is provided to mount on this grinding wheel. So both external and internal cylindrical grinding can be done on lathe by this equipment. So whatever these things are there, so this can be performed on lathe machine also. So lathe machine is, that's why normally lathe machine we are using for multiple purposes. So both for external surfaces as well as the internal surfaces also can be possible to machine in lathe machine using this kind of cutters, grinding cutters. So this is a centerless horizontal grinder. So in previously what we have seen in center type grinding machine, so workpiece is fixed or nothing but rotates in between the two centers. But here in centerless grinding machine, normally we don't have any kind of holding centers like whatever you have seen in the lathe. So working center, live center as a dead center may not be there. So directly workpiece, you're directly mounted between the two grinding wheels. So there is no support from the ends, but this workpiece is rest on a work rest. So that work rest is providing some kind of support to the workpiece. In this, if you see, so this portion, this is a typical centerless horizontal grinding machine. So in that, this whatever the small portion, this I'm just making it as a red, I'm hatching it. So this is the workpiece, and these two are the grinding wheels. In that, one is calling it as a grinding wheel, and other is calling it as a regulating wheel. So both can is giving you action normally. So for heavy workpieces, both is doing the cutting operation. In small workpieces, normally this regulating wheel is not having any abrasive particle. There just wheel is there, it's not cutting. But grinding wheel used to have an abrasive particle that removing the material. And there is a two work rest is there. So this is a typical work rest. So on this, you are mounting the workpiece. So there is a laterally there is no deform, there is no support, and there's no support is required for this kind of centerless grinding. So in this centerless grinding, there is no centers to hold the workpiece. That's why this kind of grinding operation is called as a centerless grinding. And in this, there is a different kind of arrangements are there to control the distance between the grinding wheels. So what are the two wheels, grinding wheel as well as the regulating wheel? To this, maybe we having a turning mechanism, wheel turning mechanism is there. So the other mechanism, wheel turning mechanism of grinding wheel as a wheel turning mechanism of regulating wheel is there. So that whenever the machine is reducing the diameter by removing the material on the surface, so what happened that whatever the gap between the two grinding wheel is decreasing, right? Because the removal of materials. So that is adjusted by these kind of turning mechanism. So this is forcing always grinding wheel, so that so always your grinding wheel as well as the regulating wheel is in contact with the workpiece. So there is the extra attachment is required. Grinding wheel head. So wheel is mounted in the wheel head. Similarly, housing for motor. Speed control panels are there. So here maybe some kind of gearing mechanism is there where we can control the speed of the grinding wheel as well as the regulating wheel. And here maybe you having other control systems are there, and this is completely controlled by electricity. So maybe you can have electric supply, and also complete machine is mounted on the base. So this is the typical base. So work rest as well as the work rest slide. So this is the work rest. So this work rest is sliding on this portion. If it is required, maybe it can move on this slide. So this is a typical centerless grinding setup. Maybe this, if asking you in the exam about centerless grinding, please you please practice this image. So this will give you the more marks in the exam. So this is a typical centerless grinding setup. So in this, you see, so this is completely machine setup. So this is simple, the working principle. So this is the work table. So what are the work rest is there? So the work rest, and this is your cutting tool. This is a workpiece, and these are the two wheels are there. So this is a cutting tool. Sorry, this is the workpiece. So the workpiece is mounted between the two wheels. One is grinding wheel and one is the regulating wheel. And this is placed on a tool rest, work rest. So here it is called as a work rest. And if you take the top view of this one, so you see your A and C. So A and C is nothing but your workpiece, and your grinding wheel used to have some kind of small inclination is there between these two. So by this, your workpiece is moving forward and backward. The motion of the workpiece, which is moving forward and backward, is done by the small inclination. The small angle is provided between the grinding wheel and your the whatever the workpiece. So grinding wheel is nothing but your grinding these two wheels, your grinding wheel as well as your regulating wheel. There is a small inclination will be there in between, and in between you maybe have your workpiece. So by this, so your workpiece is moving forward and backward, and entire surface area of your this whatever the cylindrical portion can possible to grind. So please take a screenshot of this also. Then I will move for next slide. So in addition to this, maybe you having a vertical spindle surface grinding also. So as I told you, the surface grinding. So normally surface grinding, normally spindle is vertical. So previously in grinding machine, maybe you can see, so whatever the bench grinding or maybe tabletop grinding. So in that your spindle is horizontal direction, but normally in vertical grinding, your axis of the rotation of grinding wheel is vertical. So normally for surface grinding, normally we're using this kind of vertical grinding machine. So in that, maybe you can see some kind of column, and then the wheel head is there. So inside this there is a motor is there, which is try to rotate which used to rotate this spindle. So this is the spindle. So on this spindle your grinding wheel is mounting. So in this, so this whatever the top portion, whatever the surface portion is there, using the surface portion you're removing the material, nothing but you are finishing. So normally for surface grinding, normally using for finishing the flat surfaces, normally for flat surfaces. So because in wheel, so maybe your diametral portion is bigger than your thickness. That's why normally they're using so this portion to cut the material, to remove the surface and material from the surface. So in that again the magnetic check is there. So on that you're keeping the workpiece. This is a typical workpiece. You're mounting the workpiece. So on this workpiece, when you're rotating this grinding wheel, is removing the material. So this is a complete setup of the vertical grinding machine. The base, table, magnetic check to holding the workpiece. This is the grinding wheel. So in that maybe you having a vertical column and wheel head. So on the vertical column you having a wheel head, and this can be rotate about this vertical head. So this can be move it up and down, so that even thick, even big surface, the big dimensions of the workpiece also you can grind on this. So this is a typical vertical spindle surface grinding machine. So this is a typical vertical surface grinding machine. Maybe you can see in actual practice, it look like this. Maybe inside this, maybe you keep the workpiece, and you having a cutting tool. Grinding wheel is there inside. So in addition to that, maybe you having a swing grinder. So in this swing grinder, whatever the initially I told you, so swing grinders are there. So it's balanced. One side you having a grinding wheel, so you can change it. But very small surfaces, if you want to grind, so maybe you can use it like this. Maybe you can fix your here, and to make it the balancing the weight. Maybe other side you used to have some kind of blower, and as well as swing arm, which is mounted some kind of mass. And other side you used to have a grinding wheel. So this grinding wheel is contacting with the whatever the surfaces, so it is removing the material. Maybe you can see in this image. So maybe you see here whatever the grinding wheel is there, when it's contacting with any workpiece, so then removing the material. Frame about 2 to 3 meters long. So whatever this frame is there, 2 to 3 meters long. One end with the grinding wheel and motor. So other end with having a balancing wheel. So because it's a swing grinder, so it used to have grinding the very long surfaces. That's why we used to have this kind of setup. So to balance this, because one side you having a complete you having the grinding wheel as well as the motor. To balance this, the other side we used to have a balancing end. The surface grinding, more important thing is there. So surface grinding is one of the common application we are using. Surface grinding machines are used primarily to grind the flat surfaces. The cylindrical grinding is used for cylindrical surfaces. Surface grinding, normally surface grinding are nothing but flat grinding. So normally using for grinding are nothing but machining the flat surfaces. However, it's formed irregular surfaces can be produced on some type of surface grinding by use of formed wheels. So E is missing here. Not only flat surfaces, even some kind of wavy surfaces, some kind of maybe some kind of maybe you can say inclined surfaces you want to make, you can use this using these flat surfaces. So horizontal spindle, let's say, can reciprocate at the table, and vertical spindle is also reciprocate as well as a rotate. So maybe you can see here. Maybe you can show you the surface grinding. So this is the typical 4 different types of surface grinding machines are there. So this is your axis. On this you can mount your grinding wheel. So here you have the 4 different types of grinding wheels are there. Horizontal spindle and reciprocating table. So table is reciprocating in that. Maybe you can see horizontal spindle. So here maybe axis is horizontal and your table is rotating, reciprocating. Your table is here. So on the table you having a workpiece, the reciprocating table and horizontal grinding wheel. Here if you say rotating horizontal axis, but it's not reciprocating, it is rotating workpiece is there here. Similarly here you see vertical axis, nothing but vertical grinding wheel and reciprocating. Here vertical and rotating. Like this you used to have surface grinding machines can be classified in the 4 category: horizontal spindle and reciprocating table, that is the first one. Vertical spindle and reciprocating table, this second one. Vertical spindle, reciprocating, so this is second one. Similarly horizontal spindle and rotating table. So here horizontal spindle and table is rotating. So on the workpiece, whatever the workpiece you're keeping, so that's the workpiece is rotates. So as table rotates, along with that the workpiece is rotating. And fourth one, vertical spindle and rotating rotatable vertical spindle, rotating table. So like this you have 4 different surface grinding machines are there. So these are the 4 typical surface grinding machines: horizontal spindle and reciprocating table, vertical spindle and reciprocating table, horizontal spindle with rotary table, vertical spindle and rotary table. So these kind of 4 different surface grinding machines are there. So please note down this one. So this is maybe surface grinding also may have the question, different kinds of surface grinding machine. So then again, the abrasive belt grinder. I told you starting one of the classification of grinding machine is abrasive belt grinder. So this is similar to, I told you, this is similar to your MMS lab, whatever you're using for the polishing. So there is a polishing belt is there. So this is all the same kind of thing. Polishing belt is there. This belt is rotating. So this on this belt you used to have a kind of abrasive particles or abrasive particles can be connected like a rectangular blocks, or in this completely on this belt maybe you used to have abrasive particles. So when the workpiece is kept like this, when the workpiece is coming in contact with this rotating belt, then this portion is removing the material. This material is removed by this belt. That's why this used to called as the abrasive belt grinder. So here, endless belt of abrasive cloth. So maybe whatever is there, this is a very flexible abrasive belt. So this is normally made of cloth. On this cloth, normally if, the abrasive particles are impinge or nothing, but it is distributed uniformly. So when a workpiece is coming in contact with this belt, on the belt you have abrasive particles. So then this material is removing because of this action of abrasive particles. So this material is removing. Similarly, drum driven by motors. So these are the drums are there. So they're driven by the motor. As drum drives, then only it is pulling the belt. So support plates to prevent the giving ups. So this whatever the support plates are there. So these support plates are preventing any kind of material or any kind of things are to mismatch. This is the supporting plate. Then work applied by hand. Normally whatever is there, because normally this is using to very fine machining. So this is a flexible belt is there, so not very heavy forces. So even manual force is sufficient. With the manual force, maybe you can apply this workpiece and you can remove the material. So work applied by hand and light grinding and polishing works. Normally this abrasive belt grinding is not using for high material removal. It's not a rough grinding, it's a precision grinding. Very small amount of material only can be possible to remove by this abrasive belt grinding. So then is coming to be internal grinding grinders. Maybe I think almost we are completed 1 hour. So maybe students are maybe boring. So I'm not going to complete this internal grinding. So internal grinding maybe I will